Hello, everybody. This is Joshua Phillips. Just putting up a little sort of casual video. This will be part one of two of what I'm calling thought process and the 12 balls problem. So in this piece, I'm just going to present you a neat little math puzzle that I quite like. Talk very briefly about how you should approach it. The second part of the video to be uploaded later will be both the correct solution, some of the thought process I use to get to that solution, and some discussion of sort of little things you might have noticed along the way that are kind of interesting. So, problem is, you have 12 ball bearings that are all supposed to weigh exactly the same. But you know that one of the 12 is either slightly too heavy or slightly too light. And you have a balance scale where you can put any number of ball bearings on both sides. It'll have to be the same on both sides if it can mean anything. Assume the difference in weight is very trivial compared to the total weight of one ball bearing. And the puzzle is only using the scale a maximum of 3 times can you find a method that will always let you find which of the 12 ball bearings is the defective one and whether it is defective by being too heavy or too light. So that's the problem. I think it's a really neat math puzzle, and that's the reason I'm making this sort of put together video for it. So the biggest thing I want to emphasize, because there'll be a second video with the answer, I'll talk about it at length, I hope, is that the point of looking at the problem is I want people who are interested to sit down, write out the problem, start thinking about the problem, and you'll hit some roadblocks where you'll see a bunch of, okay, that doesn't work, will come up. And what I want to emphasize and think about both in this video and what will be the solution video is to really write down and write out your thought process and write out whether you notice anything along the way of solving the problem. That is, there's a bunch of little pieces of information you'll notice if you start thinking about how the system works. To give one little hint, if you think about how it works with a smaller number of ball bearings, like say you have 6 of them and there's 1 ball bearing and you know it's too heavy, you want to find that, how many times would you have to use the scale? But what I want to emphasize is, write out whatever thought process you have, write out anything you observe, and write out, if you get stuck, write out what you've noticed seems to be the problem. And so now this will be the last piece of the video. The reason I wanted to record this is that I've been thinking a lot about mathematics, and particularly how it's taught, and just how many people really hate it, even at a really low level. And I wanted to see whether we could talk about more the thought process of, puzzle solving, particularly mathematical type puzzle solving, and look at some of that potential there, like maybe a large part of the issue is that people don't experience math as a thought process as opposed to just puzzle answer. And the neat thing with this is that, it's okay if you can't get the answer. If you can't solve the problem, that's fine. The solution video, I'm not just going to go, here's the answer, okay, you got it right or wrong, moving on. It'll be, here's my solution, and how I got to that solution, and whether I noticed anything along the way that led me down the path to a good answer. And so if you notice anything, that's good. That's the point. If you notice, if you could solve a very simple version of the problem, that's great. If you notice some abstract observation about the problem itself, but can't solve the particular problem, that's great. If you sit down and realize, oh, this is similar to some other puzzle, that's thought process. That's what I wanted to emphasize. So I'm hoping to put up the solution version sometime soon. I wish everyone a lot of luck working on it. Like I said, it's about seeing what you can accomplish. There's no pressure to get the right answer. So, have a nice day, everybody.